This demo involves deploying an PPE detection AI application specifically for hard hat detections as a Kubernetes workload on the ZEDEDA managed edge device. This deployment ensures the real-time inference at the edge. As we are all aware that deploying Kubernetes at the edge is challenging due to the multiple reasons. Few reasons are provisioning and remote monitoring complexities. So this edge device is actually located in a far edge. Most of the edge devices, edge are deployed in a far edge location. So managing those devices and deploying a Kubernetes runtime on those devices, and it's not on a single device, it's on a fleet of a device, is quite complex operation. Orchestration solution like ZEDEDA are essential for managing edge nodes and enabling easy K3s runtime deployment across a distributed edge nodes. This demos actually showcase the complex deployment of a Kubernetes runtime at the edge, where edge workloads are automatically orchestrated within the cluster using a single-click operation. The ZEDEDA and Rancher Terraform provider were used to automate this process. To provide some insight about the model used, the model is actually derived from the open source YOLOv8 objects detection model and has been retrained to classify whether the person is wearing a hard hat or not. So basically, this demo automate the series of the steps. The first step is basically deploy a K3s cluster runtime on ZEDEDA managed edge node. Since the model need a GPU, the K3s runtime application is pre-provisioned with the GPU drivers and then configured container runtime interface, which is nothing but a container D to include NVIDIA runtime. The second step is actually attaching these clusters to the Rancher management server for the Kubernetes workload orchestration. And then once the cluster is attached to the Rancher, basically the next step is to check the status of the cluster. This will take a couple of minutes, so the Terraform code continuously check the status of the cluster in a loop. Once it is online, basically the Terraform attach the PPE detection application, which is in the form of a Helm repo, to the Rancher marketplace. Once it is attached, and then deploy the application basically in the format of a pod to the Kubernetes cluster. All the steps, what I described before, is all completely automated using the Terraform provider. So that's what is a whole of this demo. First, I'll start with this application topology. Basically, what you see here is this application is deployed on an HPE edge device where Eve is installed on the device. And then the Kubernetes runtime is installed using the ZEDEDA orchestrator. Once it is deployed, the Kubernetes runtime, basically the cluster is attached to the Rancher, where the Rancher is used for then Kubernetes application management. The cluster which talks to the Rancher over the Rancher API. Once the cluster is attached, the Helm chart is deployed. The Helm chart basically contains this hard hat detection application as in the format of a pod, and then what are the services needed for this application, along with some of the secrets needed to download this application image, the container image is all included in the Helm charts. A Helm repo, and then repo is basically the repo is stored inside the GitHub, and the GitHub reference is given to the Rancher, and then Rancher pulls this Helm and deployed it on the Kubernetes cluster. So once it is deployed, basically this application is capable of receiving multiple streams from the different sources. To give you an example, at a time it can receives multiple streams from the 3 to 4 cameras, or the user can feed multiple videos to this application. This application basically inference the received video streams and then detect the person is wearing a hard hat or not in the video stream, and basically generate the metrics for the every frame it does an inference. The metrics actually contain few information. Basically, it tells how many persons are in the frame and who are all wearing helmet and who are all not wearing helmet. And it will also display the confidence of the inference. Basically, in a YOLOv8, the confidence is basically measured, and the confidence is lesser than 0.5. that is not actually the model is not well confident. The confident result is low. When it is greater than 0.5, the confident result is high. So what this actually does is, whenever it sees the frame with an what this application actually does is, whenever it sees the frame with the lesser confidence results, it's actually captured it and store it is in the persistent volume, so that the data can be collected and retrained, and then create a new version of a hem and then redeployed on the newly retrained model can be redeployed, so that the continuous improvement of one model is actually taken care. If you see in this topology, the entire edge device and then Kubernetes runtime is actually managed by the ZEDEDA, where then the application deployed on top of a Kubernetes is basically orchestrated by the rancher. So the user need to have the two orchestrator. One is ZEDEDA for the edge device and the Kubernetes runtime management, and rancher for basically managing an application which is deployed on the Kubernetes cluster. So that's what it is. And talking about the deployment flow, as I said before, I used Terraform for automating all this process. So this Terraform code, the client code uses and two provider. One is Rancher for provisioning the Rancher objects, and another one is a ZEDEDA Terraform provider for provisioning or creating any ZEDEDA objects inside the ZEDEDA cluster. The rancher basically, you can see what are the areas what the rancher provider does, and what are the areas what ZEDEDA provides does. Basically, if you consider a ZEDEDA Terraform, it basically creates a network instance and create an application instance. It's nothing but the K3s runtime. Once then inside when inside the rancher, it's basically create a cluster, and the create cluster basically outputs the join command, where this created cluster can join to the rancher managed cluster. And then the further step, once it is all done, the further step is basically to add an hem hard hat hem to the repository, rancher repository. Once it is added, then deploy the Kubernetes runtime. Sorry, deploy the PPE application, and then download the kube configuration file. Basically, this kube configuration file can be used to manage locally the Kubernetes cluster, right? So, for example, if the administrator want to get the information about the pod, health status about the pod, he actually no need to go to the rancher. Obviously, rancher will give all this information, but having this kubecon is very efficient for him to manage it locally. That's what it is. And this is actually what our current customer deploys in day to day. All this Kubernetes deployment, this is how it has been done. They use two providers, they use two orchestrator, rancher, and to this demo is actually built to illustrate it is not easy to manage two orchestrator. You can also use Terraform to automate all this process. You can include this Terraform into their CI/CD pipeline, so that it can be easily deployed and managed. But this is not a permanent solution what ZEDEDA is targeting. ZEDEDA is actually developing a services called ZEDEDA Kubernetes Services. Once this solution is completely developed, you may no need to have a rancher orchestrator as a separate entity for you to manage. The capabilities of the rancher will be brought inside the ZEDEDA, so that you can deploy even an application on a Kubernetes runtime using a ZEDEDA. For an example, in a previous case, what we talked about is you have a rancher orchestrator to basically add a hem repo, and then deploying an application on top of a Kubernetes cluster. Once ZKS has been developed and completely available, you no need to have a rancher, so you can directly push your hem from the Git on the ZEDEDA objects, and then you can deploy an application on the ZKS cluster. Yeah, that's what it is. I will show you the Terraform basically apply that will basically create a lot of an object what we discussed before, and deploy an application. Once an application is deployed, I can show you how the hard hat detection functionality, how it is actually works. To show you before running the Terraform apply, I'm just logging into the enterprise where the device is attached. So this is an GMWTS. So I have multiple devices in this enterprise, but I'm going to use the device which is attached to the kube deploy project. Once you go to the edge node, you can see this HP demo device. This device has a GPU. I'm going to utilize this GPU and then attach this GPU to the K3s runtime. The Terraform does all of this operation. It will attach this GPU to the Kubernetes runtime, and it will also install like GPU drivers and then add an NVIDIA container runtime to the container deconfiguration. All this will be done automatically. And this is a marketplace application which Terraform is going to deploy. I think this is a category. No, this one. No. Yeah, this one. Yeah. This is the one where you can see this is a image used, and you can see the custom configuration. Basically, it does all this operation in a pre-provision stage. If you want to see how it is can be manually deployed to understand what are the parameters being included, what the parameters can be customized, I'm just showing you the manual deployment, but I'm not going to do a manual deployment here. Just for the understanding what other things are configured as part of this Edge app. Just giving an application, just giving some name, and the interface, just giving a GPU here, and then next. And this application receive multiple parameters. What is the Kubernetes runtime you want to install, and what is a mode of the what is the role of this particular application in the Kubernetes cluster, whether it's a server or a agent. So you can actually clearly define what is the role of this particular VM, and then this basically this call home. The call home is nothing but the cluster URL. Once you create a cluster inside the rancher, the rancher basically outputs the cluster URL. That's why it's need to be copied here. So that once the cluster is created, the cluster automatically talks to the rancher manager to get attached to the rancher manager, and hence there you can able to manage this cluster using a rancher. But you don't need to I have configured everything in a Terraform. That's all these things will be done automatically, deployed with very specific values, and it will bring up the cluster. Yeah. Now I'm going to the Terraform file. So this will take a couple of minutes. Basically, this Terraform scripts checks the status of the cluster. Once the cluster is online, it will basically deploy an application. Even this application need to pull a container image. The hardcore application is in the format of one container, so it has to pull a container image. The container file size is more than 10 GB, so it will take a couple of minutes to download even the images. So this will take a couple of minutes, like 10 to 15 minutes to complete this entire process. But in this video, you can actually skip certain steps if you're not actually interested. But I will also show you the entire process, like what are the different stages it goes through and all the thing. To apply this configuration, I do Terraform plan to see there's any changes. No, there's no change, and I'll do apply to apply this configuration to the edge node. So now it is actually what it's doing is it's creating a rancher cluster, and it's also creating a network instance which is needed by the application instance, and then it's basically receives the rancher URL, and then it's checking the status of the cluster. Now, if you go to the Z control, you can see that application is getting created, and then if you log into the rancher manager, you can see that there is a new cluster is getting provisioned. Once it is online, basically the Terraform code check the status of the cluster and take to the next steps. Uh, that's what it's doing now. It's basically checking the status. Since the status is showing creating here, that's what it's reflecting in the Terraform too. So once it is moved to pending, the actual stage goes to the pending and then activating and then to online state. Then it will start deploying an application on top of it. Now it says, it's again says it's still waiting for the cluster to become online. This is basically runs code in a loop. It wait for certain seconds, and then retry, check the status of the cluster. This is taking time because so the application has to become online in device. So that's need a lot of steps because we have provisioning steps. That's basically create a cluster and then install the GPU runtime, GPU drivers, and then it's install the GPU runtime. So all this needs specific time. Some seconds to minutes, some minutes like 5 to 10 minutes. So that's why it's taking a lot of time. So once it is all done, this will become active. The cluster will become active, and then it will deploy the application. Next step, it will actually go through the next step and deploy an application on the cluster. Checking the status now in Z control. Yeah, the Z control become active. Might be it is active, but still it is running the provisioning scripts. Whatever we saw in the marketplace inside the custom config, it might be still running that all the scripts. That's why it is taking time. Actually, the attached portion is at the end of the script. If you see here, basically this is a step where the cluster will get attached to the rancher manager. So this is the last stages of the pre-provisioning. That's why it is taking a lot of time. Yeah. So now the cluster, if you see the cluster status is active, if you can see, go and see the cluster is active. So once the cluster is active, the Terraform basically add an app to its workspace, basically like our marketplace. You can see that what are the charts added to that. The hard hat is added to the added as a repository. You can check the information about the hard hat here. What is the version, application version, all this information here, right? Yeah. Now it is actually creating an application. So as I said before, this application includes an container image, which is actually of the size of 10 GB. So this will also take like 5 to 10 minutes, not 5 minutes, lesser than 5 minutes to pull the image. But you can see the status also from the rancher. If you go to the cluster, it's basically you can see the Helm operation has been started and it started deploying an application. Um, Yeah. Now the application is completely deployed. It says this is a cluster ID and this is a manifest URL. You can actually download the kube configuration, the Kubernetes config from this particular URL. But we are not going to do that in this demo. But once it is done, you can see that the created container hard hat detection, basically the pod has been deployed. Along with the hem, we have also configured our services. Basically, this application need two ingress traffic. One is if you actually see in the deployment topology, this application need video stream from an external. So that's one of the ingress it's used, and then other ingress port is basically to display the results. Either it is showing the video frames with the marked who is wearing and who is not wearing the helmet, and then other endpoints to show what is an inference results, the metrics about the particular inference frame. So now the application is deployed. So what I'm going to do is I'm going to get an IP of the Kubernetes runtime. Since the services does a node port, basically it provides a node port access to an application. So we need to have that the runtime IP address to send traffic to the specific application. So good, I'm going to the edge app instance, clicking on the device application instance, going to the basic info to get the IP address of the runtime, and then going to send a traffic to this application. So I have also created a so simple the client code, which is in the format of a Docker container. So basically what it does is it sends a video frame. Yeah, the IP is same. So it's basically it sends a video frames to the hard hat detection container, which is running on the edge device. So basically it says now it is connected to the server to check the inference results. You need to use the endpoints. Like this one will show you what is an inference results metrics. Basically, it says in the frame, it found a three person wearing helmet, and this is a confidence results. To see the actual live streaming, you need to see that. So see, you can see here in this frame, you have a three persons. None of them are wearing helmet, so it shows no one is wearing helmet. Since an application run the same video in a loop, you can see the varying results. At the first stage, they are wearing helmet, so it shows as a helmet person detected with the helmet. Then keep removing, it shows the helmet is not detected, just a head is detected. This is an application, and this is what demo I have been built. Please reach out to me if you need any clarification. If you want to understand it more, please reach to me. Thanks.